that contains a square root. Okay? So an expression that contains a square root. So radical, square root, same thing. Okay? Okay. So what you guys kind of understand, let's go through some baby basics here, make sure we've got a good grasp on things. So if I say the square root of 36, what do you guys tell me? 6, okay? Does anybody know why it's called 6?
That's the answer.
Because that's just the answer, right? Because that's what you were taught. Square root of 25 is 5, right? Square root of 36 is 6. Okay, so a square root, the rule is you have to have 2 equal factors. Okay, 2 equal factors. So if I think about 36, I can break that down to 6 times 6, right? Okay, so when I break this down to 6 times 6, I have 2 equal factors, so that's my answer. Okay, that's where that comes from. Okay, so now, it doesn't matter if I write square root of 36 or if I write the square root of 6 times 6. It's saying the same thing. It doesn't matter which way we write it. Okay? So then right over here you can see I put square root of 4 times 9. It's all saying the same thing, right? They're all getting me to a 36. Okay? So it doesn't matter whether I write 36 or 6 times 6. We're saying the same thing. Okay? So the rule of thumb today is going to be, write this down, pair them up and move them out. Pair them up and move it out. Okay, that is your big rule for today. Pair them up and move them out. Okay, so when I look at number 1 here, we are going to have this radical of 52. Okay, so what we're going to do is we're going to make like a little factor tree. We're going to start breaking it down. So 52, what times what can give me 52?
1 times 52.
Okay, well 1 and 52, we've got to do something besides a 1. Can't do 1s in this.
7.2.
Okay, you said 6 and 9.
No, about what?
Okay, is it 52 got even?
Yes.
So we know a 2, right? So go ahead and take 52 divided by 2 in your calculator. 2 and what?
26.
Okay, so 2 and 26. If all else fails, start small. Start with 2s and 3s and just try to divide and see if it goes in. Okay? So now, 2, it can't be broke down. It's prime. All right? So when we hit a prime number, that one stopped. We can't go any further. You can call it 1 and 2, but we're not putting a bunch of 1s all over this paper. Okay? So just once it's prime, it's done. What about 26?
2 and 15.
Okay, 2 and 13. Okay? So now if I look at 2, can I take 2 down any farther?
No.
No. What about 13?
No.
No, because they're all prime numbers. They can't go down any farther. Okay? So now, if you break it down, make sure you're not using that. You don't have to put X's on everything, but just make sure that your only focus is the end branches, the end parts. 2 times 2 times 13 is just another way of saying 52. Okay? So it's saying the same number, just one's broken down and one's one number. Okay? All right, so now the rule. Pair them up and move them out. Do we have the pairs on the end of the branches there?
Yeah.
What? A pair of what?
2.
Okay, so we have a pair of 2s. So we're pairing up, and that gets to be moved out. Pair them up, move them out. Okay? So on the outside, I have a 2. It's just the pair, all right? You don't put 2 times 2, or there's not 2 2s. It's a pair, you pair it, and you move it. Okay? So once you circle it, it becomes 1 1 2. Okay? 2, and then do we have a leftover guy? Yeah, poor 13 didn't have a buddy, did he? So he's stuck on the inside. And he just stays there. Okay? And this is going to be your answer, 2 radical 13.
Did we do the math,
We did some square root work, not quite this intense.
like where we broke it down?
We did do factor trees, yes. So we're taking the 2 ideas and putting them together now.
If we did this on one of our calculators, like the yellow one, would it have the exact same number?
Yes. Okay, so the question is, if I put square root of 80 on here, will it give me the answer? Yes, that's why you can't use it. Okay? So if I put, if I backtrack, if I put the square root of 52, you guys remember how you were getting those weird looking things, 5 root 2, and then we would double arrow it to get the decimal? Well, that weird looking thing, that's what that weird looking thing was. That was the
Oh.
radical answer.
Hey,
Okay.
well,
So these guys will give you the answer, hence why we're not using them. All right? Now, are you going to use the yellow calculus on your final exam?
Yes.
Yes. So if you know how to type it in, then you're gonna have some of the answers already right off the bat if you know how to type in a square root, okay? But you will not have access to the yellow ones until after you turn in that quiz next Wednesday, okay? So you've gotta be able to do this by hand, primarily it's for geometry, we've gotta be able to do square roots in geometry, okay? Alright, radical 80,
8 and 10.
okay?
2 and 40.
I'm hearing all kinds of stuff, 240, 8 and 10. Whoa,
Or
calm down,
20.
guys, stop yelling. It doesn't matter. Use 2 and 40 or use 8 and 10. It doesn't matter, okay? So I'm gonna go ahead and do 8 and 10, okay? All right, 8, what's the 8 gonna break into?
2 and 4.
Okay, so 2 times 4, and then the 4 will break into
2, 2.
2 times 2. All right, now break down your 10, what will your 10 break to? 2 and 5. Okay, now again, keep in mind that we are not using anything we broke down. So if you have a branch coming off of it, it's out of the game. Okay, you do not have to put X's all over your paper. I just want to kind of reiterate that. If you broke it down into something else, you don't use it. Okay? So now, do I have any pairs?
Yes. You have 2 pairs of 2.
Okay, good. We have 2 pairs of 2. All right? So what is, in this case, you're going to take 2 times 2. Just multiply the circle. So 2 times 2 is 4. So I have a 4 on the outside because I paired them up and moved them out. And what do I have left on the inside?
5.
Okay, we have a 5 left on the inside. Okay? All right, does anybody have a question on that?
Now when it be.
Yes, sir.
Can you, okay, so did I have to like rewrite how you did that? Because I did put 2 and 40 and I broke all that down.
That's fine, but you should still have 2 pairs of 2s.
Yeah. I did.
Okay. Yeah, that's fine. Another question? Good? Okay? Go ahead and try number 3 on your own then. Try number 3 on your own. Yeah, and so if I have, yeah, multiple pairs. Right, so 2 times 2, that's 4. That's the 1, 2, it's just a 2. No, it's a circle. Pair them up. So pair it up, then you move that guy out. You only have a pair of 2s on that side. Okay, let's go ahead and start talking about this. All right, 120. Kevin, what'd you break it into to start with?
2 and 60.
Okay, 2 and 60. Okay, then where'd you go from there?
2 and 30.
Okay, 2 and 30. Then where?
2 and 15.
2 and 15.
And 3 and 5.
3 and 5. Okay? Now, you could have broken it down a different way. This is just one of many. But you should have 3 2s, a 3, and a 5 at the end if you did it right. Okay? So now, when I'm looking for a pair, I have 1 pair of 2. So what's my outside number here?
4.
No.
2.
2. Okay? It's not 2 times 2. You pair it up. When you pair it, it becomes 1. So it's a 2. And then on the inside, you've got a 2, a 3, and a 5. What do we get there? 30.
So we're gonna multiply all of those 3.
Always multiply, yeah. And so you multiply what goes out, and you multiply what stays in. Okay? Yes.
So like for on number 2, when we had 2 sets of 2, so like
when we have like multiple sets of 2, do we add those together
No,
or
you
do we
multiply.
multiply them together?
So it's 2 times 2 is 4, and then this 5 is left over.
So like if we had 4 sets of 2, then that would
Then 2 times, that would be like 16, oh, no, 64, so 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, so there you go, okay? Alright, okay, number 3. Apparently the second number 3. Alright, so if we're looking at this next guy here, okay? There's a number on the outside, we don't really care, we'll worry about him later. So what we're going to do though is start with our 180, just like we've been doing on the first couple problems here, and we're going to break it down, okay? James, what do you want to break 180 down into? What did I say, Lynn? Okay, 2, and then 90.
Oh, that's a 20 and 9.
Okay, so now, it's okay if you do something different, but now what would 90 then break into?
2 and 45.
Okay, that'd be fine, 2 and 45. Then 45 would go to
9 and 4. I mean, not 9 and 4. 9 and 5.
5. And then the 9 would have to go to 3 and 3. Okay? Alright, so now you're still pairing up. So I have a pair of 2s and a pair of 3s. Okay? So you're going to pair them up and you are going to move them out. Okay? There's already a 2 on the outside. Okay? So you're going to take 3 times 2 times the 2 on the outside that's already there. Okay? So you pair up, move those out, and then multiply all that by the 2 on the outside. So what's 3 times 2?
6.
Times 2?
12.
12. So you have a 12 on the outside. And then on the inside,
5.
we have a little 5 left over. He didn't have a partner, so he's stuck on the inside.
Wait.
What about
Oh,
the
wait,
nine?
I get it.
Oh, it is not
What about that?
No, I was gonna ask like how.
Okay, anybody else have a question? Everybody understand where that 12 came from?
Yeah.
Could you explain that again?
3 times 2 is 6 times the 2 that's already out there. There's already a 2 out there, you gotta take 2 times whatever you're moving out. Okay? Alright,
So-
anybody else?
Do you have like, okay, so like you could have like multiple sets of different numbers. So let's say you could have 2, like one set of 2, one set of 3, and one set of 4, and then you'd like just like multiply those
Yeah,
together.
then you would multiply them.
And then like, is there a chance that you will not have like a prime number by like, or I mean like, all right, let's say like you had another 5 there somewhere. Is that like, what would you do
We're
with
gonna
the
write it
inside?
back. Hang on, okay. Alright, so now you're gonna see a problem like this. Okay, you multiply insides with other insides, outsides with other outsides. It is segregated. You cannot intermix things, okay? So what I'm talking about, if I look down here at, on number 6 down here, I cannot take 3 times any of the inside numbers, okay? Insides multiply with other insides, outsides multiply with other outsides. You cannot intermix, okay? Does that make sense? Alright, so if you're looking at this one, since they're both on the inside, we can go and just multiply them together. So what is 2 times 24?
48.
Good. Okay, so we're going to have the square root of 48. Alright, now breaking down. If you are wise, if you multiply this wrong for some reason, okay, but if you just use the 2 and 24 that you used to get there, it won't matter if you mess up this guy, because you're going to use the 2 numbers they gave you anyway. Now, could you use, 4 and 12, yes, 6 and 8, yes. You can break down whatever numbers you have, but if they've already given you numbers, especially when they get a little bigger, it's easier just to use what they already gave you. So 2 and 24, and then where would I go from there?
2 and 12.
2
Or
and
2 and
12.
Or 3 and 8.
Okay, yeah, all those will work. So then I'll have 3 and 4, and 2 and 2. Is everybody okay with all that?
Yeah.
So now pair them up. So let's see, we have a pair of 2s and another pair of 2s. So 2 times 2 is
4.
4. So 4, what do I have left on the inside?
3.
3 on the inside.
Yay.
So 4 root 3. Okay? Alright, anybody else have a question?
Nope.
Nope? Okay. Alright, so let's go ahead and multiply on number 5. Someone tell me, when I multiply those together, what do you think the answer should be here?
2 on the outside and square root symbol and then 45.
45 on the inside, very good. 2 has to stay on the outside. Guys, there is technically a 1 in front of any square root, just like a variable, okay? So 2 times 1 would be 2. 3 times 15 is 45. Okay, take a second, break that one down. See what you come up with.